Welcome to the Arsenal demonstration for SBOMPlay. SBOMPlay is an SBOM exploration and intelligence gathering platform. This platform is fully in-browser and fully client-side. Now, SBOM, as we also know as software bill of material, there has been a lot of discussions around SBOM. In 2023, I did a presentation around Beyond the Code SBOMs, where I basically argued that SBOMs are not the entire scope of the supply chain ecosystem. In 2024, I was trying to find a solution of what is the use of SBOM. And I talked about the fad, the future, and what could be done at multiple conferences. At this time, I wrote my first version of SBOMPlay, which was written in Python. Then in 2025, I ended up creating the version that we see right now. Now, the core idea behind SBOMPlay is to prove that SBOMs can be useful outside of security industry also. And the way everyone is right now positioning SBOM, there are far more other usage about SBOM than just the information security angles. And what I've realized is it's far better to show rather than just do talks. So in the system, you provide either a GitHub URL or a username or an organization name, or you upload the SBOMs. So we support both modes, either a GitHub entity or a direct SBOM upload. The only requirement is if you're providing me a GitHub input, the GitHub repositories should have dependency graph enabled. Now, in a nutshell, this is what exactly we do. We take the input, we fetch the data from the browser using GitHub dependency graph. Once we have all of this data, then from your browser itself, we make queries and gather all the other data. Once I have all of that data, I do processing and give you interactive view about the data that we have gathered. Now, one of the core principles behind designing this tool, as I told you, I wrote this tool earlier in Python. I moved to the browser architecture because I wanted to create something which is very privacy preserving. Now, this tool, you don't even need to run it on the website address that I'm showing you. You can basically go to the GitHub repository, download a zip file, run it by just double clicking on index.html. Every single request that I'm making, there's no middle person involved. All the requests are going away from your system to the respective servers, and you're getting all the results back. Now, one concern that comes up is you might have URLs where you're sending data. So you can create an air gap compatible system by allowing access to a certain set of endpoints. I've given you the list of endpoints that are needed, and that will allow you to run this whole tool without exposing it to the internet. Now, once we have received the SBOM, we start by first trying to resolve the SBOM dependency tree. We go 10 level deep, and as I'm showing in the diagram on the side, we query these ecosystems in parallel. So right now you can see there are a bunch of different ecosystems that we are querying because I gave it a repository set where there were multiple ecosystems involved. Now, once all of it is done, you get a dashboard similar to what you see right now. This dashboard gives you a high-level overview of how many repositories, what are the dependencies, how many vulnerabilities, how many licenses are there, how many direct dependencies are in need of a sponsorship, if there is any author that is in need of sponsorship, any security issues that are there, and how the ecosystem split is there. Now, from this point on, there are a bunch of different screenshots that I've shown, which are effectively talking about how this tool operates. Now, I can either continue showing you all of these screenshots, or I would much rather prefer that I go and do a direct demo of the tool. So this is how the tool looks like. As you can see, I've opened the index.html page, and this is hosted on github.io. So there's no backend that can be used here. It's all HTML, JavaScript here. This is where you provide the different URLs, either a org name, a username, org/repo name, or a direct repo name. Or you can click on upload SBOM, and provide SPDX JSON or Cyclone DX JSON. Once you've provided these, you click on Start Analysis. If there is too many requests that are going to happen, you might get rate limited. So the way to avoid rate limiting is provide a GitHub token. This GitHub token does not need to have any permission at all. Just a blank GitHub token is good enough. And you can use that to gather a large chunk of information. Now here you'll see these are two scans that I've run. There is a dependency tracker specific repository. So there is one repository about 431 dependencies there. There's an upload dep confused. So this was a SBOMP upload that I did. And there's one repository, bunch of different dependencies in here. This dashboard view has a lot of data inside it. Two of the very interesting data is most commonly used dependencies and dependencies with version sprawl. So among the repositories, among the dependencies that we are using, there are multiple versions of dependencies in use. So those versions are highlighted here. Now, I'll walk you through each tab. So if you go into the license tab, you'll see there are a bunch of different licenses. The most important field for us here is the license change. What you'll see here is WordWrap, which is a dependency, has 0.02 version in MIT X11 license. But when it went to 0.03 version, it became an MIT license. Similarly, ES6 symbol moved from MIT to ISC. Now, what is ES6 and where is it used? So if I click on it, I get to this view, which is from dependencies section, where I have searched for this specific dependencies. So yes, all the filters work client side. You can see this is used by one repository. And in one version, it has ISC license, in another, it has MIT. Let's see more details. So when I click on this, I can go on package registry from here. So this takes me to the ES6 symbol package registry. You can see the version that is here. You can go on versions. And if you scroll down, you can see the old versions. And let's see the versions that we have. 3.1.1 and 3.1.3. So we'll open 3.1.1 from here and 3.1.3 from here. So now 3.1.1, you can see the license is MIT. And on 3.1.3, you can see the license is ISC. Now, these licenses may be compatible. These licenses maybe do not pose any change, but there is definitely a change in license. And I'm not trying to be a license expert. I am just showing that there is a difference and you might want to understand what is the license change that has happened. So that's the license form. Under vulnerability tab, this is where you'll find the classic security issues list. What we've done here is we've not just provided you all the issues, we've also provided you directions. Like for example, Pillow, there's a major version available. In Pillow, there are many bugs that are in there. For each of the bug, all the detailed advisory links are available here. You can click and get more details. Where is Pillow used? Pillow is used in dependency tracker. Now, as you see, for each of those issues, there are multiple line items. What you'll also find in some of the scenarios, like this scenario here, where there's a dependency that is in use, but this dependency is not directly in use. We have Plazo in our dependency tracker, which is using OpenSearch PY, which is using OpenSearch protobufs, which is depending on protobuf. So the entire tree from where we are finding this vulnerability, we have also listed this. So this is about the vulnerability tab. When you go into the audit tab, this is where you get a large chunk of audits around SBOM itself. So as you can see here, I'm showing that this one is a Cyclone DX SBOM. This one is an SPDX SBOM. And if you click on details, you can see compared to CISA 2025 minimum elements, these are the entities that are missing. So there's no dependency relationship. There's no component hash here. Compared to BSI, we are missing dependency relationship component hashes. Compared to certain, we're missing a bunch of more details. So I'm telling you, these are the compliance requirements. Once they're met, then your SBOM would be compatible to that specific standard. Similarly, if you look at dep confuse, you will see there are a few entries which are missing, and then again, per certain, there is more things missing. So that gives you a compliance view of your SBOM, the document that you'll be sharing with people. Now, the findings tab is interesting. It takes a bit of a time to load because right now it is doing a lot of calculation and computation. And after that, it comes up and shows you the details about the environment. So while this loads, I will open dependency view in the tab. Now, dependency view is where you can actually see the live dependencies, the transitive dependencies, and other details, including if there is a dependency which is end of life, if there's a dependency which is not maintained anymore, if there are minor drifts from the version, so the version that you have and the version that is latest, there's a minor variation change, or if there is a major drift, or if there are packages which are looking for sponsorship, and or if the packages are vulnerable. So we've got these cute little filters that will help you find out the right details very quickly. The repository view gives you per repository view of where the SBOM grades are, the vulnerabilities that are there, the dependencies that are there, and if there's any licenses discovered on those dependencies. Now that brings me to the authors view, which is the last view. Now this particular view, before we go there, finding tab has given us all the details. So let's quickly look at the finding tab. Here, there are 131 findings. There are 7 dependency confusion, potential dependency confusion. There are 112 potential end of life. Now, what do I mean by end of life? There's a section where we are listing number of packages which have not been updated for 3+ years. So they're likely abandoned. So no update for 8 years, no update for 8 years. So if I go and open the package registry from here, you'll see, and if you go to release history, the last release was 2017. So this package has not had any update for a long time frame. So they're highlighted here. Now, similarly, we have probable end of life. These are not updated for 2+ years. Does not mean that they are all obsolete, but it's just that for a brief period of time, there has not been an update. We have listed the last release dates here. So you can see that, yes, there is a big gap between today's date and these dates. There's potentially dependency confusion because these are the package URLs that you're not able to find on the PyPy registry. So either these are taken down or something has happened, but these packages were not available on the package registry. So there's a possible dependency confusion scenarios. The GitHub action ones is where there is a GitHub action in place and it is not pinned to a SHA commit, but rather to a version string. So we're marking it as unpinned action references. Similarly, if there is a mutable tag reference, we are highlighting those also, because these tags, when they're not pinned, there's a chance that some change can happen on those tags, and that would affect this particular environment. So that said, let's get back to authors section. So in the authors section, what we've done is we've extracted all the top authors for all the dependencies that you had, and we've aggregated them out. Like, for example, this Hugo Van, this person has developed a bunch of different packages which are in use by multiple repositories. So that's highlighted. So this list is arranged based on the impact that the person has on your environment. And if they have the location mapped, we list the locations also. All of this location is also available over a map. So you can see where the contributors for your projects are coming from. And all of that detail is available here. If there is a social network listed, we have listed those. If there's a sponsorship available, so like this person has opened a sponsorship page, so we show that also. Now, this is where I'll draw your attention towards the settings page, because there's an interesting setting that we've added. So this settings page allows you to tweak these settings a bit so that your scans can be better. Like, for example, if you feel your environment has more than 10 levels of depth, add those depths. How many parallel processing has to happen? What is the batch size? All of that is here. Right now we have a 10-second API timer. Do you want to change it? You can change that. But this is what I wanted to show you, the sanctioned countries list. Now, we live in a world where there's so many conflicts happening. We don't know which country is our enemy, which country is our friend. So let's say, for example, in a certain scenario, a certain set of countries are not are friendly at this point in time. And let's say you CN and IN and let's say GB. I've added a bunch of different entries. So I can save these become organization sanction list. And now what happens is if I go into the authors tab and I click on show only authors from sanctioned countries, I will get a list of all the authors that belong to the country that I've marked as a sanctioned country. Now this helps me in identifying who are the people that I may not want to have in my repositories. So now obviously, I don't want all of these to be barred, so I'll remove all of them. There is no configuration here now, and the authors tab would work fine now. Another thing is if you want to remove a specific dependency or rather a specific scan, you can go here and remove it. All these scans are exportable and importable. So you can export from one end, import everything on the other side. There's also cached DB and export analysis. So cached DB and export analysis, the difference is cached DB caches these details. The author entries, the package entries, the vulnerability entries, the relationship. It's not the actual SBOM data, but it's the relational data that we have gathered. And so you can either export the analysis, cache DB, or export everything. And then similarly import these things separately. There's also a debug tooling interface where there is some additional cache management options that we have provided. In case you are stuck and you want to do something quickly, these debug tools will help. Now, about section is where I've described all the things. Like, for example, I talked about air-gapped deployment. So these are the domain names and subdomain names which need access if you want my service to run properly. End of life becomes a bit tricky. So what we consider end of life is what we've documented here. Then we have archived repositories, we have dependency confusion attack details, all the details around the standards that we're using, the vulnerabilities that we're finding, how we are finding them, what we are doing with them is all listed here. So that covers the whole run of SBOMPlay. I would highly recommend all of you to go ahead and play around with it. So I'll go back to the slides quickly. So you can see license compliance, change, authors, geography, common dependencies, version sprawl. All of this we have covered. This is in a nutshell a view of what SBOMPlay is. Automated vulnerability scanning, license compliance, author and funding details, deep dependency resolution, everything gets stored in the IndexedDB and everything is client side. Thanks a lot for attending the session. Have a wonderful day. And this is how you can connect with me. That's my email address. That's my handle available on all social media. This QR code will take you to the repository. This is the repository address, and this is where you can find the source code of the repository.